we got closed-toed shoes. 2, your hair needs to be tied back if you have long hair. So just put in a hair tie. I had a hair tie somewhere if you need one. If you don't have a hair tie or don't have one that you could borrow from someone, okay, I just won't let you hold it because I don't want anybody's hair to start on fire. That would not be good. Number 3, I want you to take off all jewelry if you're going to hold the fireball. Okay, take off all jewelry. Watches as well, so jewelry and watches. Okay, you are going to remain calm, okay, and I'll be standing next to you. So what I want you to write down is remain calm and follow instructions. Okay, so I will direct you on what to do. You are going to remain calm. Some people freak out. I had a kid last year literally throw the snowball that was on fire. Luckily, it landed on the table. Okay, nothing burnt down. Okay. Are we number 4 or number 5? Where are we at? 5. Okay, fire extinguisher. Okay, the fire extinguisher, I want everyone to know, is right over here on the wall. Right there. Okay. If something happens, and let's say I drop it and my rug starts on fire, I am putting Mike right here in charge of grabbing the fire extinguisher in case we need it. Now, ethanol, you guys, is an alcohol and it burns off really fast. So even if we did drop it on the carpet, it takes a second for the carpet to ignite and we would most likely be able to put it out just fine. Plus I have 2 buckets of water right here that we would also aid in that situation. I don't ever want that to happen, so I need you guys to follow my instructions so that that doesn't happen. However, when accidents occur, right, if we are prepared and we know how to respond to that accident, can we essentially mitigate any consequences of the accident? Yeah, we want to be prepared. We want to know what to do in case something does happen, right? Yeah. So, fire extinguisher over by the door into Mr. Leo's room, okay? Now, scientific method review. I have it as 7 steps. I think we did it yesterday as 7 steps. What was step number 1?
Observation.
Observation / question, right? Observation / question. We're out in nature. We see something. We want to understand more about something. We want to know why something happens, or if there's a specific condition, does something always happen when there's that condition present? Okay. Number 2, hypothesis. Develop a hypothesis. If you want to put a little description by these, you guys, on our quiz at the end of this unit, okay, you will have a matching section. And you'll have to put them in order. So you'll match up function and step, and you'll put them in order. Does that make sense? So just so you know, that's what you have to know for scientific method. Number 3, what do?
Test.
We test it. We run an experiment. Okay? As we're running our experiment, what are we collecting? Data. We're collecting data. Okay, number 5, we analyze our data. We run statistical analysis. Okay? We look to see if there's any correlation or relevance or significance. All of those words you would want to use in your writing. Okay? When looking at your experiment. Number 6,
Conclusion.
we draw a conclusion. Okay, and last but not least, what do we do with our results?
Publish.
We publish them. We share them with others. Okay? And then sometimes we have to go back and retest and redo it and such as that. Okay. So I'm going to describe what we're going to do. All right. And I want you guys to make your own hypothesis and predict what's going to happen. Okay. So first question: what do you think will happen when we combine calcium acetate and ethyl alcohol? Okay. So let me show you what those are. This is calcium acetate. I will come around. It is just a white powder. Okay. You guys see that? It is actually used as a medication, okay, for people who struggle with kidney function or digestive issues. Okay. It is just a white powder. Okay. And people take it for medicinal purposes. All right. It's not something you would buy over the counter, something you'd get as a prescription, right? But that's what it is. Calcium acetate. Ethyl alcohol. Where did I say here? This is ethyl alcohol. Okay. Does anybody know what is ethyl alcohol? What is it? Does anybody know what type of alcohol it is? Okay. This is like this is alcohol that you would drink normally. Ethyl alcohol is produced via fermentation, okay, and anaerobic respiration processes with yeast, okay. However, in a lab, do you think you could drink this?
Yes.
No. This is 95% and it is denatured. What does it mean if I say that something is
5%
denatured?
alcohol.
Yeah. If I say that something is denatured, what does that mean?
No good.
It's no good. So, if something is denatured, it means bonds have been broken, okay? And they've changed the structure of it. When you change the structure of ethyl alcohol, if you consume it, what do you think happens? Yeah, it will kill you, okay? So, you cannot drink this. It is not like a beer, okay? It is not like that at all. So, it has been denatured. It is toxic. Do not ingest it, all right? We're good with that? Okay. Ethyl alcohol has some really cool properties, okay? How many of you have used hand sanitizer? Anyone?
Yes.
Okay. Hand sanitizer has alcohol in it. Now, depending on the type of hand sanitizer, sometimes you'll have an ethyl alcohol, sometimes you'll have an isopropyl alcohol, okay? But hand sanitizer has alcohol in it. How quickly does that evaporate off your hands? Really fast, right? I mean, like you put it on and you go like this and it's like gone, right? It evaporates really, really, really quickly, and that will help us when we go to do this lab. Another awesome characteristic about ethyl alcohol is it burns at a really low temperature. So it doesn't have to get that hot for it to start on fire, for it to ignite, okay? And that will also help us in our lab, okay? So I want to know, I'm going to take this white powder, calcium acetate, and I'm going to dissolve it in 20 milliliters of water, okay? So we're going to start with that. Beaker. This is a beaker, okay? This is a piece of glassware that you guys are going to want to be very familiar with. We have different sizes of beakers. In this lab, this is a 400 ml beaker. This is a 2,000 ml beaker, okay? So as you can see, these are drastically different sizes. However, this is the same piece of glassware, just different sizes, okay? I'm also going to use a graduated cylinder, okay? Have all of you seen one of these before? Yes? Okay. I have a stir rod, which is a little magnetic bar, okay, that I will put, and I will be able to stir and dissolve our calcium acetate in water. And I want to get that going, so I'm going to do that first. If you are starting to write down supplies, you're going to have some materials, you're going to have some methods. As I go, just fill those in, okay? So materials so far, we have our calcium acetate, which I set right here, and I have 6 grams of calcium acetate, so I would quickly write that in. I'm going to measure out 20 mils of distilled water. How do we measure water in a graduated cylinder? Does anybody remember? What do we look for? What is that? The U thing. What is that called? Starts with an M. The meniscus.
Yeah, I would not have guessed that.
Okay, So you want to find, that little U thing to make sure that you have the right amount. And that allows you to measure your solution more accurately, okay? So, I have just a teeny bit more that I gotta get out of here. Now, I am putting 6 grams into 20 mils. How many of you have heard of concentration before? Okay, what does concentration mean? Like if you were going to describe it.
A lot of things in a small area.
A lot of things in a small area. Okay, so how many things are in a given volume of space, right? Okay, so we have a little stir plate here. Hold on. If you have a lot of something in a small space, do you describe that concentrated or not concentrated? Concentrated. Okay, so that is stirring, and now I'm going to add my calcium acetate.
That's cool.
I don't want it to clump up, which is why I have it stirring as we go. I want it to dissolve completely. And this is going to make a saturated solution, meaning there is a lot of solute per given amount of solvent. And we'll learn about solutes and solvents later in the year as well. What is a solvent? Does anybody know? Close.
The thing that dissolves.
The thing that's doing the dissolving, okay? Usually it's the thing that's in the greatest amount. Water is considered to be the universal solvent, okay? It is polar, has some really awesome properties in it, pulls stuff apart, and things can dissolve in it easily. Okay, so I'm gonna let that continue. I also need approximately 180 mils of ethyl alcohol. Because I don't have to measure it as precisely as I did the water, so I used a graduated cylinder to measure the water because I wanted it to be more precise. I don't have to do that with the ethyl alcohol, so I'm just gonna pour it in my beaker. Not that one. Where's my little one? Thought I had another little one. I obviously don't. I'm gonna grab another small beaker. Time out, hold on. Thought I had one over there and I did not, okay? And I'm just gonna roughly put 180 mils in another beaker. I'm going to pour my alcohol over here by the sink because I don't want to spill any excess alcohol on the table. Why do you think that is? It could easily ignite, okay? Yeah, it could easily catch on fire. So I'm gonna pour it in over here. Okay.
20 mils.
Nope, need a little bit more. I was trying to read it looking down. Don't do that. When you're looking at measurement, okay, pull it up so it's eye level or set it on the table and lower yourself to eye level. Okay, so that's about right. Now, as you saw, got a little alcohol on the table. I don't want this anywhere near where I'm going to be, which is why I did it over here. Okay, so now we have our ethyl alcohol. Let's check on this. It's dissolved pretty well. I don't want any chunks, so I'm just kind of checking to make sure there isn't any chunks. Swirl around the stir rod a little bit just to make sure that any of the excess got off the stir rod. Okay, which it looks like it has. Okay. I'm going to unplug this so that I don't fall and trip. You want to take away any potential hazards that you could have in the lab. Now that I'm done stirring, I'm just going to take this off. Okay, so now back to our hypothesis. Jump back to your hypothesis spot. I'm going to mix these two together in this beaker. What do you think is going to happen? Okay, I heard some fire. What else? You think it's going to freeze? Okay. Get harder. Okay. Write down what you think is going to happen.
Fire and combustion.
We are quickly running out of time. Quickly running out of time. So I'm going to pour these together and show you really quickly what happens. And I accidentally left my stir rod in there.
Oh no.
My bad, but it's okay. I can just pull it out.
Oh, let's go.
Okay, I will come around and show you what happens.
Slow.
Okay,
Whoa.
what do you see?
No, that's
Snow. This is why it's called the why it's called the California Snow Demo. Okay, what would you call that? Slush, gel. It's called a colloid or a suspension. Okay, I'll let you guys touch it in a minute. You'll see what I did. Okay, so we made a colloid. Now I'm going to make this into a ball. So I'm just going to kind of grab it out. I want to come off. I don't want my wash on. Okay. And I'm gonna like squeeze as much of the excess alcohol off as possible. Why am I doing that?
Boom.
So it doesn't drip. Yes. Why else?
Less is more.
I'm squirting. It's not good. Okay. I don't want excess alcohol because alcohol burns easily. Okay, and the more alcohol in there, the more burning that's actually gonna happen. Okay. All right. So now we have our fireball. I'm going to set this over here out of the way. I'm also going to wash my hands because I have alcohol all over my hands right now. So I'm going to rinse them off. Okay.
You dip your hand in water.
And dry them just to make sure that I spilled a little bit of alcohol, so I'm just wiping down my table really quick to make sure that I don't have any excess anywhere. I'm going to remove my name tag. Okay. Can all of you see this? All right, now would be a time if you would like to come up, and I want you guys to, first we gotta grab some goggles. I gotta grab some goggles. Goggles should have been on your safety list. I totally spaced that. We wear goggles for labs. Right here, these are splash guards, and this is totally fine for this lab for you to use splash guards. So I want you to come over here, grab a pair of splash guards, and then kind of gather by where Titus and Jacob's sitting. So just kind of like gather so everybody can see.
Over here to film with you.
Yeah. You got some eyewear? Okay. I want the eyewear on. You guys can gather right here, just as long as kind of everybody's lined up here so everybody can see. Okay. I'm gonna light this. Everybody's goggles are on. Sweet. Oh, come on. Okay.
Woo!
That is burning. Now I'm gonna see there was a little bit of alcohol on the tray. I'm gonna let it burn off really quick. Want it to cool off as the fuel gets used up. There isn't as much on the surface. Okay, so it's actually burning more interiorly, which makes it easier for me to pick up. When we do this lab, we always coat our hands in water. Okay, that's going to be a protective measure for my skin. When I pick it up, I'm going to pick it up and treat it kind of like a hot potato. I'm not going to let it just sit on my hands, okay? I'm going to kind of move it carefully back and forth and then set it down. Does that make sense? Okay, so dip my hands in water here. It's still the flames. Can you see how high the flames are with my face? You need to be really careful as you're doing this. So dip hands, okay? I'm going to try it out and see. It's still pretty hot, so I'm going to wait a second. If you get alcohol on your hands, just put it in the water. Okay? Okay, just like that. But I can pick it up, I can handle it. I don't know if you guys can see my hands burning because the light is pretty light in here right now. But you'll get alcohol on your hands will burn, and you just put them in the water. Okay? Whoa. And they'll go out, and it's just fine. Still pretty hot. Okay? Just like that, hands in the water. Okay? Don't hold it, and don't toss it. Would anybody like to try? Want to try, Mike?
There's Michael.
It is hot, so you're going to dip your hands in the water, carefully pick it up, set it down, hands back in the water. Okay? It'll get hot after about 2 or 3 passes. Okay? It is still on fire, you guys. It is still on fire, so dip your hands. Coat your hands in water. Okay? Pick it up from the bottom, hands back in the water. There you go. Yeah. Nice job. All right, good job. Go ahead and go wash your hands. Mike, do you have any lotion to put on afterwards?
I don't.
Okay, it's all right. I have some you can use. You guys, the burning alcohol will actually take the oils off of your skin more than even just hand sanitizer. So, does anybody else want to try? Justin, come on down. Okay, you don't have it. Okay, sweet. Hands in the water. Nice. Hands back in the water. There you go. Hands back in the water. Nice job.
That's cool.
There you go. You can say you've held a fireball.
Yeah.
All right. Who else wants to try? Ryan, come on down. Ladies, any of you have a hair tie?
I do.
I'll
try.
Okay.
I'm a wizard. Ooh, it's hot.
It's hot. Does put off heat. Fire puts off heat, right? Okay, hands back in water.
That whole fire in my hand.
Back in water.
Oh, my hand.
So sometimes you get a little bit of residue on your hands. That's why we
Right.
dunk it right back in the water.
I had snow in my hands and it was burning me.
Okay, hands back in water. Nice job. Nice job. All right, Georgia, come on down. You guys, the bell is going to ring. You guys can stay for a second and continue. Make sure you fill in your appetizer since we didn't do it at the beginning. Hands back in water. Nice. Good job.